Thanks all for joining, and then again, apologies for being a minute or two late here. Some technical difficulties with the link. I'll give it one more minute for folks to filter in, and we should jump in shortly thereafter. So I'll give it one more minute. All right, let's jump in. I know folks will join as we get started, and I think we have anyone who is waiting to join as we kicked off here. So let's jump in. My name is Andy Gower. I'm a solutions marketing manager here at Portworx, and I'm joined by my friend and colleague Bhavin Shah, our technical marketing manager here at Portworx as well. And today we're going to talk about machine learning with Kubeflow and Kubernetes. Very exciting topic, very timely topic. And we're going to spend the bulk of the time on the demo, but I am going to spend about 15 minutes up front talking about Portworx. So if you're new here, what we are, what we do, why it's so important to you and your business, and why it's an instrumental part of any Kubernetes deployment. And then I'll turn it over to Bhavin, and I'll let Bhavin run the show with the demo and talk to the ML with Kubeflow and Kubernetes portion. So feel free to ask questions. The chat is open. We'll keep an eye on them throughout the presentation, and I'll try to answer them as they come up. And if you've got any at the end, we'll hold for questions at the end as well. So I'm going to start talking about the application development market and why it's really changing what we're doing and why Portworx is a critical part of that change. So I think we all know and can accept that data is powering the business of tomorrow. And I think even the slide's out of date, right? It should be data powers the businesses of today. And that's a fundamental shift we've seen really in the past 18 months, as we've seen an acceleration from the analog business, where I go to a storefront and exchange money for a goods or service, to the digital storefront, to the digital world, where everything I'm doing is happening digitally with data underpinning everything. And so data is really powering that next evolution of the business. And in order to do that, digital leaders are using the cloud native stack so they can process that data into value and insight and roll out new features, new functions, new applications, new things to their customers so they can be successful. And that cloud native stack is really built upon a multi-cloud infrastructure with app-driven automation with Kubernetes and containers, and a plethora of new data apps and data services, things like Cassandra and Kafka, Cloudera, Elastic, Spark, and others that are really putting this new cloud native stack into play and driving a set of new people and processes to harness this data, to process this data. Things like DevOps, things like GitOps, things like data pipelines. And all this comes together to create a stack that allows us to unlock power of that data. And what we know is true more than anything is that containers and Kubernetes is what's really allowing this engine to blow up, really allowing this engine to go into full force across the board. 95% of new apps are being developed in containers. 81% of enterprise are working with 2 or more public cloud providers. 78% of CNCF members are using Kubernetes in production, and 85% of global businesses will be running containers in production by 2025. So containers and Kubernetes are here to stay, and they're powering this next evolution of the business. But we also know that Kubernetes alone does not address key business requirements. It doesn't address things like HA, backup and DR, data migration, security and compliance. These are fundamental things that we need to address in order to put our applications, our data services, our mission critical workloads into production on Kubernetes. Now we know that this is especially true when we think about the storage and data management layer. There's a set of traditional storage that's out there, and as you start to scale it, as you start to scale the stack on top of it, the storage doesn't quite keep up. We start to run into problems around, how do I easily move my data between clouds? How do I protect that data? How do I make sure that it's delivering the performance I need to be in line with my SLAs, to have cross AZDR, to have backup and restore, role-based access control, compliance and governance? These are all things that are key to a deployment in production, but traditional storage doesn't quite address. And the reason for this is fairly simple. When we look at the legacy world, it's very infrastructure centric. It's infrastructure heavy. Everything we did in that world was tied to the server and the storage. We provisioned the server, we monitored the server, we backed up the server, and everything was really tied to that layer. It wasn't really talking or tied to the application layer. But what we know is that in Kubernetes world, the app is king. The app is the center of everything we do. And so we need a set of infrastructure that can come and go as the app grows, that can be provisioned with the app, that can observe the app, that can scale with the app, that can protect the app, but can do that off and on. It can do it as the app moves to different locations, as the app moves from on-prem to the public cloud, as the app scales up and scales down. So we need a storage that is centered around the app, not centered around the infrastructure. And to really drive this point home, just double clicking on that, when we think about legacy storage, there's really three areas where we really fall down a little bit in a way that legacy storage can't quite keep up with container native storage. So when we think about legacy storage, we think about the fact that we had to handle maybe hundreds or thousands of volumes. When we think about containers, we have hundreds of thousands of containers, each with their own volume. So that's a scale that's significantly different than the traditional storage that we've been dealing with. We also have the challenge of human versus machine administration. So in the traditional legacy world, a human would be really optimized on 10 to 12 clicks, 10 to 12 very intense processes that help power that system. Now, in the Kubernetes world, we have hundreds of API calls a second. So how could we possibly have a human ramp from 10 to 12 commands to hundreds of commands a second? That's a scale that the human just can't address. We need some machine help to help us really scale to that level. And the last piece is storage services are locked to the infrastructure in the traditional world. All those services are tied to the underlying array. But as I mentioned on the previous slide, we are constantly wanting to move our apps around. So we need those storage services to move with the app. We need those storage services to be present, whether you're running it on-prem, whether you're changing backend infrastructures, whether you're changing backend cloud infrastructures. We need the storage services to be locked to the application, not to the infrastructure. Now, when we think about developing a way to address these, of course, container native is the thing that comes to mind. It's what we're all talking about. It's what is kind of top of mind as the next evolution, how we take the storage and put it into the Kubernetes platform. Now, as we think about this, there's really four key elements that the strategy with Kubernetes storage must envelop. You need to be able to abstract the storage away from the infrastructure so that wherever the app runs, these services are one and the same and available wherever the app runs. You need to be able to build for scale. So you need to be able to handle that scale of tens of thousands of volumes a second, hundreds of storage operations per second. You need to be able to handle that volume. You also need to be able to expect that the app could range in sizes. It could be small, it could be big, it could be running at the edge, it could be running on-prem. We need to have a consistent storage framework to handle that variability in our app. And we have to have reliability. We have to be able to deliver those core storage services reliably with HA and with DR and with consistency across anywhere that application runs. Now, there's really two main approaches that we see that are common in the industry today. On the left is the connector approach, the CSI approach. And this approach really helped unlock the idea of persistent volume claims with your storage, but it has limitations, right? So at the end of the day, the CSI spec is tied to the underlying storage array. So you're dependent on the capabilities of the underlying array. You're dependent on the array actually being there. You're dependent on the innovation that is in that CSI spec. And many times that could be limited by what the open CSI spec is at the time. So you don't have the flexibility to take a CSI driver from, say, the orange array and use it with the green array. You have to use whatever capabilities are built into the CSI spec with the orange array. And most importantly, when you have CSI, you're dependent on, in this connector approach, you're dependent on the Kubernetes and storage being managed independently and having to line up almost in the field how they actually coordinate with one another. You need your storage administrator and your Kubernetes administrator to really be working hand in glove to make sure that the Kubernetes layer and the storage layer are working together because they're being managed independently. Now, in the container native approach, this is all about virtualizing the underlying storage. So we have one common storage pool, and we can provide consistent storage services at the container granular level and the app consistent level across the entire pool. And what this means is we can provide consistent storage services across any infrastructure. We have the storage encapsulated in the virtual volume, so it can move with the container as opposed to being stuck in place on the array. And most importantly, it's managed as a native part of Kubernetes. So we extend the automation of Kubernetes down to the storage and data management layer, so you get the benefits in the automation of Kubernetes, and you don't have to worry about the coordination between the storage and the Kubernetes administrator. Okay, so that's kind of where the industry is. What is it that Portworx does specifically to address these? So first, if you haven't joined us before, we are a leader in this space. We've been recognized as a leader in both cloud native data storage and enterprise Kubernetes storage. And we also work with a number of different customers of all sizes on a lot of different problems. So if you have a challenge or you're facing something in your field, we've probably seen it before. We've probably worked with it before. We probably helped address it before with another customer. And so we're able to leverage that experience to make sure that we are providing the services that you really need to go into production. We also work with a number of partners. You name the Kubernetes distribution, we work with it. We work with them closely. IBM, Red Hat, AWS, Google, VMware, Rancher, and more. So we provide consistency at whatever platform you're running. Now, what exactly are we delivering? So the Kubernetes Data Services Platform, Portworx, is really focused on delivering a set of 6 core storage and data management services on top of any Kubernetes distribution with any application. So whatever database you're using, whatever streaming service you're using, whatever search service you're using, it's consistent. There's one consistent control plane. And we do this on top of any cloud as your cloud infrastructure or any on-prem infrastructure, whether it's bare metal, whether it's pure storage, it's all consistent. And we provide a single control plane to manage and deploy these data services. And we do this at every stage of the application lifecycle. So from pilot to test dev to going live to going in big production globally. So what are these 6 modules? What are those storage services I'm referring to? So there's 6 key ones. The first one is PX Store. PX Store is focused on providing that software-defined storage layer that automates the container storage for developers and administrators. And for many people, this is the key thing that's first in unlocking production workloads, right? You need to have a software-defined storage layer to move into production with your mission-critical workloads. The next is PX Migrate. With PX Migrate, we make it easy to move your applications between clusters and between clouds or between different data centers on-prem without you having to be locked in anywhere. So you can move your applications around. You can move them quickly. You can move them easily. You can do things like DR, synchronous and asynchronous. You can do things like having a backup or a burst in another location. And we make that easy to do with PX Migrate. And importantly, we capture not just the data, but we capture all the Kubernetes artifacts associated with the application to make it simple and easy to do that migration and pick it up and move it somewhere else. The next is PX Secure. So we know that, of course, security, ransomware, all of these things are top of mind day in, day out across the board. And so we provide a framework for you to implement consistent encryption, both at rest and in motion, and also to ensure that you have things like role-based access control and other key abilities to implement your security framework to prevent unauthorized access to the data. The next is PXDR. So PXDR is a very important one. In PXDR, we are able to provide that 0 RPO requirement for data centers in the same metro area and a very fast RTO. So for customers who are looking to ensure that they have HA and DR between AZs or regions and clouds, PXDR helps to fit that bill with that 0 RPO requirement. PX Autopilot is focused on providing optimizing your scale. So as you're using a cloud backend, rather than over provisioning upfront because you're anticipating your application scaling, you can put rules in place so you only scale when you need to. By doing that, you can save tremendously on your storage costs, on your cloud storage costs. And last but not least is PX Backup. PX Backup is focused on backup and restore of your cloud native apps. It was built from the ground up for containers and Kubernetes, so it speaks at the container granular, at the application aware level, so that you can back up and restore entire namespaces, entire applications quickly and easily from one location to another. You can move them between clouds. You can restore to any S3 endpoint. It's a lot of flexibility with PX Backup to provide you with app consistent backups for your cloud native apps. Now, before I turn it over to Bhavin, I want to quickly talk about 4 interesting case studies where we were able to put Portworx in production and have success with our customers. So the first is T-Mobile. So T-Mobile, every year has one of the biggest launches of the year they have to handle, right? The new iPhone comes out. Apple comes out on stage and they say, we're launching a new iPhone, and everyone rushes to their phone vendor like T-Mobile and says, is there a way for me to buy this today? Is there a way for me to find out the new features? And so on a regular basis, once a year, T-Mobile has to go from handling their web backend on-prem to bursting it to the cloud so that they can handle the huge lift in surge of traffic. The other thing that's really important for them is the ability to roll out new applications. So when there's a new iPhone launch, maybe there's a new feature they hadn't planned for, and they want to roll out a new marketing campaign. Well, being able to deploy an app quickly is a key facet to keep up with that launch. By putting Portworx in play, T-Mobile was able to A, do that bursting, do that movement from on-prem to the public cloud once a year to handle the surge in traffic. And they're also able to reduce app deployment time from 6 months down to hours. So they're able to come up with a new concept in the morning and deploy it that afternoon. The next is Roblox. So Roblox, as we all know, is a big gaming company. And at the beginning of the pandemic, they scaled in 1 week as much as they had the previous year combined. So that's a generational shift in scale. And you have to be able to handle that scale. You have to be able to ensure that as this generational shift happens, you can scale out your entire backend to support it. With Portworx, Roblox is able to provide that scalability and give them the agility they needed to quickly ramp up and build out their platform to support that rapid growth in gameship. The next is mobility and reliability specifically. So RBC is an interesting one. They were using Kubernetes and Portworx for a few different areas, they're using Kubernetes for a few different applications. And they came to Portworx with a problem. They said, we want to put this banking app in production at scale, but we have to have 0 RPO because it's a critical banking app. We can't go down. It's key to our business. We need help putting together a DR solution that can address that. So working with Portworx, we were able to put together a 0 RPO DR solution with 2 independent data centers so they could have the confidence in deploying that app in production and knowing if one data center failed, they could fail over to the other and that key app would always be online. And the last one is cost saving. So Audi Business Innovation, they came in for speed and agility and reliability, but what they found along the way was cost saving. So they were running on AWS, and by using Autopilot, by using that optimized scaling, they're able to cut their storage bill by 60%, their AWS storage bill. So they got all the benefits of Kubernetes in containers, but they also cut their bill along the way. So these are just 4 examples, and I'll turn it over to Bhavin here in a second. If you're interested, both after hearing me talk and after hearing Bhavin show the demo, please feel free to check us out for the free forever trial, the Portworx Essentials, the free 30-day trial, which is full featured, the PX Backup trial, which is a 30-day free trial that you can use separately from Portworx Enterprise. And of course, please join us next month for the demo on 12.14. We'll be talking deeply about PX Backup 2.1 and really going into the feature and functions that are new in 2.1. So with that, Bhavin, I will turn it over to you. Were there any slides you wanted to show first, or do you want to take the screen for the demo?
So yeah, let's do the first slide about Kubeflow, and then we'll switch to the demo and then come back to the last slide. Thank you, Andy. So hello everyone, my name is Bhavin Shah. As Andy introduced, I'm a tech marketing manager on the team. Today we'll be talking about Kubeflow and how Kubeflow provides a framework for organizations to run their machine learning pipelines and machine learning projects on Kubernetes. So basically the way Kubeflow works is anywhere you can run Kubernetes, you can go ahead and run Kubeflow. So that gives you the ability to train your models in AWS with GPU backed instances and run inference locally at edge locations. Once you have your models trained and do all of this, because Kubernetes provides that consistent platform, orchestration platform, and Portworx provides that consistent storage platform across all of these Kubernetes clusters. If you haven't been keeping up with Kubeflow, or if this is the first time that you're hearing about Kubeflow, Kubeflow came out with version 1.3 and has added a lot of modules as part of its deployment. So today we'll be specifically focusing on creating Jupyter notebooks and creating an ML pipeline that helps us prepare or do data preparation using a data set that we downloaded from Kaggle, do model training with GPU-backed instances, and then run inference locally. We will look at a couple of benefits that Portworx brings to the table. So we'll look at how you can dynamically provision persistent volumes based on storage classes that your administrators have defined for you. So as data scientists, you don't have to go and worry about provisioning storage. You don't even care about storage. You just care about training your models, storing it securely so that next time when you need to iterate on it, or if you want to transfer it to a new location, you can do that with convenience. We'll also talk about how you can iterate on different versions of that trained model. So using volume snapshots from Portworx. And then we'll also look at how you can use PX backup as the data protection solution to not just protect your entire machine learning pipelines, but also ensure that if you want to restore that same pipeline or same model to a new Kubernetes cluster, you can do that using a simple web-based interface, a UI-based interface. So with that, let me start sharing my screen and we will jump into the CLI. I'll change the presenter and okay, perfect. So everybody should be able to see my command line interface, and let me know on chat if this is not readable and if I need to increase the size of the text. So here we have a simple EKS cluster running in the US East 1 region. The benefit of running Portworx with an EKS cluster, like again, there are different benefits that we'll talk about in an AWS specific monthly demo session, but then specific to Kubeflow, you can have EKS cluster which have storage nodes and which have storage less nodes. So storage nodes is where Portworx can run and provide that layer of persistence for your machine learning models. But then you can also have storage less nodes as a different node group in your EKS cluster. And this is the node group that you can scale up and scale down based on when you are actually doing model training in your EKS cluster. So you don't have to pay for GPU instances all the time, but you can still store all the models securely on your storage nodes. So in this cluster, we have a 3-node storage cluster and a 4-node, a 3-node storage-less node group, which has GPUs in it. So we have already installed Kubeflow version 1.3 using Customize on our EKS cluster. And if we look at everything that's running in the Kubeflow user example namespace, so we have a bunch of pods running. As you can see, we have a simple pipeline up and running as well. If we do get pods, get PVC, you will see that we have data sets and models as which are provisioned using the shared storage class, which is a read-write many storage class, whereas the workspace directories for all these inference, preparation, and training notebooks are read-write ones that are dynamically provisioned using our standard storage class as well. So let's look at all the different storage classes there are in our EKS cluster. So we have different storage classes that you can leverage from Portworx that are pre-installed on a fresh installation, but we have configured 2 new storage classes, the shared and the standard. And let's look at the configuration for this shared and standard notebook. So for shared, we definitely want to use shared equal to true, allow all IPs equal to true for this demo. We have set the replication factor as 2 because so any data that's written to any persistent volume provisioned through the storage class will store 2 copies on your EKS cluster. So even if you lose a node in your EKS cluster, you won't have any data loss and you can continue serving traffic. The reason I'm showing you the YAML file in a demo is I wanted to highlight the snapshot schedule that you can specify as part of the storage class itself. So here we have a local snapshot, which is a local snapshot that's using a schedule policy that's called daily. And then we have a cloud snapshot that's storing snapshot of all the persistent volumes that are created by the storage class into an S3 bucket, and that's using a different schedule policy. So basically, whenever a data scientist comes and creates a new notebook using the Kubeflow user interface and creates new volumes on the backend, they get provisioned dynamically through the storage class, and automatically also get snapshot schedules that help them go back or roll back to a different version, that help them make sure that if there is an accidental deletion or accidental failures, they can still roll back to a state where they had a working copy of their model or a working copy of their trained data. So that's our shared -sc storage class. We also have a standard -sc .yaml file. So again, this is a read write once storage class, so only block volumes will be provisioned through this. Here we are using a replication factor of 3 just to show that using Portworx you can customize all of these different settings and get benefits at the storage layer. IO profile is set to auto. By auto, we'll basically look at the IO for a certain amount of time, and based on the profile that we identify, we'll set that IO profile for you. So instead of DevOps admins or infrastructure admins having to figure out what the application write pattern looks like, they can just set the IO profile to auto, and Portworx will handle all of the remaining things under the covers for you. The standard storage class also has a couple of snapshot policies. So a local snapshot uses daily schedule policy, and cloud snaps uses the weekly and interval schedule policy. So let's look at what the different schedule policies that we have available. So here we can see that we have our daily and weekly interval. If I do a kubectl describe on the daily policy, here I'm basically asking Portworx to take a snapshot every 30 minutes, and then on a daily basis, so every day at 10:14 p.m. it takes a final snapshot at the end of the day as well. So that's what happens as part of the daily snapshot policy. For the weekly and interval, it takes a snapshot every 15 minutes. It pushes it to our S3 bucket, retains 5 copies, and then at the end of the week on Friday at 10 p.m. it takes one final snapshot. So you can customize this as you want and have your own retention and snapshot schedules and where you want to store these snapshots. But this is what we have configured for this particular demo. So now let's navigate to the user interface for Kubeflow and look at our notebooks. So I'm right now, you can configure load balancer endpoints or node ports or cluster IPs. Right now, I'm just doing a simple port forward. So that's why I'm accessing the Kubeflow interface using 127.0.0.1:8080. And here you can navigate, like obviously to the home, you can find more resources, find out how you can create these different pipelines and notebooks and models using Kubeflow, or you can go to the volumes tab. Here you can create new persistent volumes. So even if the data scientist or the machine learning engineer, ML engineer doesn't know how Kubernetes works, they can still create their own volumes and specify the size. If they don't select anything, standard SC is configured as the default storage class on my Portworx cluster, so that's what they'll use. And if they want read write many, they can choose the shared SC as well as the storage class to use. But this is how easy it is to create new volumes. If we talk about Jupyter notebooks, so I've pre-created a few Jupyter notebooks, and I've ran one iteration of the data preparation, training, and inference just to make sure that we have a good state that we can use to demo volume snapshots and backup functionality. But these 3 notebooks, again, as a data scientist, you can come here and create a new notebook. You can give it a name. Specify the container image as the custom image that you can specify. You can specify the resources. So on the backend, a notebook basically translates into a Kubernetes stateful set, and each stateful set will have pods associated with it. So what you're specifying here are nothing but resource limits and requests for the different pods that are spun up as part of this notebook. So you can specify resource requests, and you can also specify resource limits through the Kubeflow interface. And then for GPU, again, if you are actually going ahead and running model training, you can select the number of GPUs that each instance has, and you can select from a drop down whether you have an NVIDIA or an AMD GPU. For workspace volume, again, by default, each notebook, each pod will have a workspace area of its own, like a temp volume. But as part of the pipeline, we'll use a couple of shared persistent volumes for all three notebooks to share. So let me exit out of this, and let's look at the data preparation notebook that we have created. Data preparation, we still need it to be a big enough pod so that it can process my data and make sure that it's ready for model training. So here we have selected 4 CPUs and 4 gigs of RAM, but here I don't need any GPUs, so I haven't selected any GPUs as part of the notebook definition. If you look at the volumes that are created, you can see that I have mounted the datasets volume, the shared volume that we have created on the preparation. So basically, when we upload the data and have this Jupyter Notebook prep it for model training, it will store the CSV files in our case in this datasets shared volume. And next, when we actually go ahead and do the model training, we attach the same persistent volume to the training notebook. So it reads data from the datasets persistent volume and writes data to the model's persistent volume. As part of training, we still want it to be high on resources, so 4 vCPU and 4 gigs of RAM. But for training, obviously, it will be faster if we can attach a GPU to it. So since my EKS cluster has GPU instances as part of the node group, it will automatically provision this specific pod on an EKS node which has a GPU attached to it. And then for inference, it's pretty simple. Like, it doesn't have to be resource intensive. We'll just do a 2 vCPU, 2 gigs of RAM, and no GPUs, and we'll just attach the model's persistent volume that will be used for this is where our inference workload or inference notebook will use or leverage the trained models and run inference for us. So let's connect to the data preparation one and see how it works. So I have an IPYNB file that's running. I can, as a data scientist, I can write code here. This is what I interact with on a day-to-day basis. I can import my modules and run data preparation. This example file is available. We'll publish blogs after this, monthly demos, and you can find these if you want to try out a simple machine learning pipeline where we train a model which differentiates between a dog and a cat. It picks up after the model is trained, it picks up random images from the internet for a cat and a dog, and then you can validate whether your model returned the correct answer or not. So here you can basically come and run all the different cells. So if we scroll through it, it imports a bunch of modules. We have uploaded a train.zip file which has a bunch of training data. It has a bunch of dog images and a bunch of cat images that it uses for data preparation. And then it basically takes that, processes the data, and at the end it generates a couple of CSV files as the output that is stored in my datasets folder. So if I come back to the datasets folder, I can see that since I've done this one earlier, I already have the CSV files that are needed for my model training. So let's go to the next step in the pipeline, which is the actual training. So we'll connect to our training notebook, and here we have a training a notebook file, and then you can see the datasets and the models persistent volumes that are mounted at specific locations inside our pod. They show up here as well. So if I actually click on the datasets, I'll see the same CSV files that were created by my data preparation phase, but they show up for my model training. So this is where we'll fetch it from. So let's go to the training notebook, and similarly, similar to how we did the data preparation, the data scientist can come here and train their models. If we scroll down, you'll see that it basically reads the CSV files, looks at the data that's uploaded in the datasets folder, and then scrolling down, it basically runs 20 iterations on the data till it hits an accuracy of more than 90%. So with more than 90% accuracy, it can tell you whether the image that you have uploaded as part of inference is a cat or a dog. So you can do the same thing. You can run all the cells, and since we have a GPU attached to the pod, it takes about 30 minutes to an hour to run the training. So we won't do a training live, but again, we'll upload demos later where we'll show how this process works. But you can basically see what it does. It goes through all of the 20 iterations, increasing the amount of accuracy that it gets. So it started with an accuracy of 62%, and then when we finished, the accuracy was 92%. So we know that our model has been trained correctly, and we can, with guarantee, almost a guarantee, we can say that whether the uploaded image is a cat or a dog. So at the end of the training phase, it stores a couple all the model files or all the assets that the model training phase generated, and stores it in the model's persistent volume. So here you can find these .pb files, which are your trained models, which is what will be used for running inference. So let's go to the inference notebook, and then let's connect to it. And here in the inference notebook, we can basically look at the same things over and over again. Here you can see that we pick out a random image of a cat from a website called placekitten.com, and then run it against our model to show whether it categorizes it as a cat or a dog. And then we have an image of a dog that we download and run it against our model as well. So let's actually run this inference and see it in action. So we started let's do a run all. So the things that have asterisks behind it, they are not run yet, but as you can see, we basically ran all the steps and the cat image changed, and we got the correct answer. Like, okay, this is a cat image and this one is a dog image. So that's like the basic way Kubeflow works. And the benefit that I wanted to highlight was, okay, this is how you can dynamically provision persistent volume, because as a data scientist, all you know is this Kubeflow UI. You don't care about the underlying infrastructure, how storage is provisioned. So if you have those storage classes pre-created for all the different phases of a machine learning pipeline, the persistent volumes will be automatically created, snapshots will automatically be taken, and if you have backups in place using px backup for a specific namespace, all of this will be backed up as well. So let's navigate back to the CLI and look at volume snapshots. So we'll clear the previous ones, and you can use a simple command called kubectl get volume snapshots in the kubeflow user example.com namespace. And here you can see all the different volume snapshots for all the different persistent volumes that have been created. So here you can see the local snapshots, and you can also see the cloud snapshots for the dataset's persistent volume and the model's persistent volume. If you want to roll back to a specific time of day where you had a standard or a gold image of the model being trained or the data being prepped, you can roll back to it. So let's another thing that you can do using snapshots is, let's say as a data scientist, I'm happy with the model that I've trained. I want to pass it to my teammates to make sure that they can optimize it further, they can make improvements to the model. And so instead of having to ask them, okay, go ahead and use this data set, prep your own data, train your own models, and try to hit the same accuracy, they can start with a good enough starting point and then run their own model training and like improve the trained models on their own. So for that, how Portworx can help is, we can take one of these snapshots and create a new persistent volume from this snapshot and upload it to a new notebook. And this basically gives you a second copy of your trained model that your teammate can keep iterating on while you still own the golden copy. So for this, we have a test pvc.yaml file. This is how you can create a new persistent volume from a previously taken snapshot on Portworx. So we give it a name. Again, we're just using test-clone, a simple name. We can specify the snapshot that we want to restore from, or the snapshot that we want to use to create this new persistent volume. And then this particular volume doesn't need to be shared across different users, across different phases. So we'll just use read write once and use a store snapshot sc storage class to provision this volume. So let's go ahead and apply this YAML file. Oh, actually, I need to apply it in the correct namespace. So let me delete this and then apply it in the Kubeflow user example namespace. So if we do a kubectl get pvc in the same namespace, and let's just do a watch command on it, you can see that we have our test clone, which is in the pending state. So it takes a few seconds for the persistent volume to be provisioned. In the meantime, what we can do is we can go back to our Kubeflow UI and start the process of creating a new notebook. So we can create an infer-test notebook. This is, as part of this exercise, you're just using a model that's already been trained and using it to like run my own inference, and then I can figure out if I need to improve the model any further. So we'll use a custom image. For this example, I already have an image that's available on Docker Hub. So if you want to use that, we'll use 2 CPUs, even like 1 CPU, 1 gig of RAM. We don't need any GPUs because still we are just doing inference. And then for data volumes, I can just do existing volume and use the volume that we just created from the new snapshot. So the volume name is test-clone. So we can specify this here and mount it under models directory as well. So instead of using the models persistent volume, we are using a test-clone persistent volume, which is basically a snapshot from one of the previous iterations of our original persistent volume. Once our PVC is up and running, we'll hit create to basically get access to it. Let's see why this volume isn't coming up yet. If we have to change, we'll change the snapshot ID because we only retain a specific number. I might have used the snapshot name from a snapshot that was taken earlier in the morning, which was like way before the 15-minute intervals take place. So let's describe the PVC and see what's going on. Okay, so yeah, it is complaining about snapshot not being found. So let's identify a new snapshot that we can restore from and create that persistent volume. So let's choose a snapshot from like 33 minutes back, and then let's delete the kubectl delete the chef. And then we'll update the YAML file with the correct snapshot ID. Okay. Now let's go ahead and apply the YAML file again and wait for the persistent volume to show up. You can also do a describe this time and see if it liked the change. Okay, so it's not giving any errors. While we wait for this persistent volume to be provisioned, let's talk about PX backup and how that can help you protect your application as well. So we have a standard PX backup installation running version 2.0, and we have added our primary cluster, which is the cluster that we were interacting with. And we have added an inference cluster that's running on in a different region inside AWS. So here you can see that you can select the Kubeflow user example.com namespace and then create a new backup. And PX backup allows you to take an end-to-end backup. So it includes everything from your persistent volumes to deployment objects to to stateful sets and any pods and services that are created for your machine learning pipelines, and you can create this backup job. As part of the demo, we have already created a backup after we had trained our model successfully once in the morning. So you can see that we have had one successful backup that's existing on this cluster, and this backup is stored in an S3 repository in AWS itself. What we can do is we can perform a restore operation. So restore for inference, and we can select the destination cluster. Here we can choose to select all the objects that were protected. So as you can see, we have authorization policies, config maps, deployments, notebooks, persistent volume claims. All of those different resources were protected as part of this backup. You can choose to restore all of those, or you can just choose a few resources. So instead of selecting all, you can just select the two persistent volumes that you want to restore. The cluster that I'm restoring to doesn't have any of these resources ready to go. So we'll basically select all resources that are included in this backup and create or perform this restore operation from our source to our destination cluster or our inference cluster. So let's see if like while the restore is active, let's see if our test clone persistent volume is up and running. So yes, so we were able to create a new persistent volume called test clone from a snapshot that was taken 33 minutes back. So let's just copy this, go to our Kubeflow UI, make sure that the name is correct. We are mounting it to the correct directory. We have selected the right image, the right amount of resources, and then we can hit launch. It takes a few seconds for this notebook to get provisioned as a stateful set and create pods for it. And then as soon as it's up, we'll basically connect to it, look at the trained models. Our notebook is already up and running. So we mounted that test clone as a models directory. If you look at it, we have that folder called one and the .pv files that were originally trained. So we were able to take a snapshot of the original persistent volume, and once it was in a good enough state, we took a snapshot, we restored a new persistent volume, and now we can iterate on it and run inference using this stored module as well. So let's go back and upload our inference file. So IP1B and then infer dot, and then you can upload this here. We can navigate to it, and it's basically the same inference that we saw earlier. Like it picks up a random cat image and then compares it against our model. So we can click here and select run all and see it in action. So it's using the model, downloading a new image and giving us output that that's a cat, and then using the sample1.jpg and then giving us a result that, okay, that's a dog. So we took a snapshot and we used it for a different inference notebook completely. Let's see how our restore operation is doing. So what we can do is we can definitely monitor it using the user interface, but let me go to the CLI, switch my cluster context. So I'm using the restore cluster, and we can monitor more activities from there. So let me just use EKSCTL to change my context to the new cluster. If we do a kubectl get nodes, here you can see that this EKS cluster doesn't have any GPUs. All of these are M5.2x large instances that are just running Portworx and are ready for our machine learning inference workloads. So if we do a kubectl get pods in the Kubeflow user example.com namespace, and again, this is where you can see that our inference is in the init state. Our preparation and training are in pending, so it takes a while for them to come online. But all we need is inference for this demo. So as soon as that's up and running, we'll go ahead and navigate to the UI. So as you can see, our inference, both the pods are up and running. One thing that we'll have to do is, if we go back to the Kubeflow UI, we'll have to log in again, because now we are pointing to a different instance of Kubeflow. And I can log in using the same credentials with my super secure password. And then once I log in, I can navigate to notebooks. I can see that inference is ready to go with 2 CPUs and 2 gigs of memory. That was the original configuration that I had when the backup was taken. And the preparation and training are still in the container creating state. So I can connect to the inference notebook. I see that my models directory, my trained models are already mounted, and my IP1B file is also here. So I can navigate to it and then run all the cells again, just to make sure that I can take the trained model that was trained on a GPU backed cluster, and I can run inference locally at an edge location which doesn't have the ability to have GPUs locally. So that's it. Like for this demo, let me ask Andy to share the slides again, and we'll have one summary slide, and we can open this up for questions.
Perfect. Thanks, Bhavin. And let me take the, yep, perfect. So,
yep.
There we go.
Thank you, Andy. So yeah, like 4 things. Okay, it looks cropped. I don't know why. You can just put it in like the slide mode, and we'll just talk to it. So 4 things to take away from this presentation is why Portworx for Kubeflow, right? Like, okay, it definitely helps you with dynamic provisioning of block and file volumes. You don't need different solutions or different connectors or different backend systems to provision read-write once and read-write many persistent volumes. Portworx can provide all different kinds of protocols from a single storage layer, a single storage pool. High availability and replication. We saw how administrators can configure different replication factors so that any data that's being written to the Kubernetes persistent volume is replicated across nodes. So even if you lose a node, even if you lose a pod, your data is still there, so ensuring no data loss. Local snapshots and cloud snaps is like the third thing. So you can have your local snapshots. We saw that we were able to like create a new persistent volume from a local snapshot, and I was glad that it worked out in a live demo. And then similarly, you can do the same thing with cloud snap. So you can use a cloud snap that's stored in S3 and restore from it on the same cluster, or you can use cloud snap to restore it on a completely new cluster itself. And then you can use PX backup as the data protection tool, so you can protect your Kubeflow pipelines, not just Kubeflow, right? If you're running any and all applications on Kubernetes, PX backup can help you protect those and then restore it to the same cluster or different clusters. And I think that's it for me, Andy. Close it out.
Perfect. Any questions? I know we've got a couple minutes left. I didn't see any in the chat. Feel free to drop them in as we wrap things up here. I just want to flash this up one more time for those of you who want to explore this a little more on your own. We do have the Portworx Essentials, Portworx Enterprise, and PX Backup available as free trial options at portworx.com/free trials. There's some guided tutorials in there as well, so please check those out if any of this is interesting to you today and you want to dive in a little more deeply. And then last but not least, again, we'll be doing this again next month, and the focus will be PX Backup 2.1, all the new things we've launched with that. We announced that about a month ago, GAs very shortly, so that'll be an exciting topic to wrap up 2021. I don't see any questions left in the chat. Any last call for questions? And if not, thanks everyone for joining today. Hope you have a great Thanksgiving coming up here in a couple of weeks, and we'll see you for the monthly demo next month. Thanks a lot, all.
Thank you.